All right, folks, today we'll work on some scientific notation. And, it has a lot to do with exponents because we can, do some operations with scientific notation while they're in that form and to make the math a little easier. Quick review of writing things in scientific notation. Remember, you can have a number, 1 through 9 to the left of the decimal place. You don't want any zeros there. And then you can have some numbers to the right of the decimal place as well. And then for the exponent of the 10 base, for each order of magnitude of 10, you would have an extra number there. So what do I mean by that? Let's look at some examples here for you. So if we look at number 8, 540. Again, we can only have one number to the left of the decimal. So it'd be the 5, it's the first number. And then the 4. Now you don't have to write a trailing 0. That would make no sense, so you can eliminate that. But to get from 540 to 5.4, you had to move decimal places. Well, we started here, it went 2 places to the left. So you're going to say it's times 10 to the 2. Now the question is, with scientific notation, is this a positive or negative number up here? Well, it's always a positive number unless the number itself is between 0 and 1, which is a very small range. Those are the decimal numbers. Those are the ones that we have a negative up here for the exponent. Well, 540 is not that, so you leave it as a positive, and that's the answer. Another example right below it, 630,000. Again, we want the decimal to be right here. So the decimal originally started this place, so it's moving 1, 2, 3, 4, 5, 6 places. Actually, 5 places. I count 1, 2, 3, 4. 1, 2, 3, 4, 5. It's 5 places. I can't count. So it's 6.3 times 10 to the 5. All right, how about numbers that are between 0 and 1? Well, number 14 here is less than 1. It's more than 0. Again, having only one number to the left of the decimal place, that would be the 4. So we put the decimal here. Well, it's moving 2 places, 1, 2, to the right. So it's going to be 4.57 times 10 to the 2. And again, because it's between 0 and 1, that's a negative number. Another example of those is on 0.000045. Giving the decimal to be here, giving us one number to the left of the decimal. So 1, 2, 3, 4, 5 places. So it's 4.5 times 10 to the 5th, but it's minus. Okay, now, we can go both ways. So sometimes you have to go from scientific notation to standard form. So here's some examples here. I'll just do a couple with you. You see, you have a negative number. As I said earlier, negative numbers mean the numbers between 0 and 1. So it's going to be a decimal. So when I move this 3 places, it's going to move, not this direction. You want to go to the left. So we have some zeros in front of that 7. So we can go 3 places, 1, 2, 3. That's the decimal, 0.00711123. Standard form. Some of these are big numbers. I just noticed that. Over here, number 18, you'll try. It's moving 5 places is positive, so we don't want any decimals. So we're going to go, it's going to be 6, and then the decimal's right here, so we're going to go, this will be 1 place, 2, 3, 4, and 5. So it started here, 1, 2, 3, 4, 5. That's the new decimal place right there. So the answer is 625,000. All right, that's going from scientific notation to standard form. Now, we can do some math with these. And the scientific notation actually helps make the math a little easier at times. So, again, we're doing with exponents here. When we multiply a number like number 29, we want to take the numbers out front, the 6 and the 5, multiply them together. And then the base 10, 10 to the 8th and 10 to the minus 2, and multiply those together. So 6 times 5 is 30. And then for the base 10, it's going to be times 10. Now we do the math, remember we just add the exponents. So you have 10 to the 8th plus 10 to the negative 2. That's going to give me 10 to the 6th. Now some of you are thinking, well, there's my answer. Well, not quite, because 5 times 6 got us to the 30, didn't it? So my decimals are here. I'm going to let that one number to to the left of the decimal. So I'm going to move this over here. So now I have 3.0 times 10. Now when I move that by order of magnitude of 10, I have to change my exponent as well. And here's kind of the rule. As you make the numbers smaller, as you make this number smaller, you got to make this one bigger. And vice versa. If you make that number bigger, you have to make it smaller in the exponent. Well, I went from 30 down to 3. I made it smaller. So I have to make this number bigger from 6 to 7. That's a little tricky to keep that part straight. I know it. All right, look at the next one. Now we have division. Again, I want to divide the front end of this and then the exponent part of it. So 4.5 divided by 9, hopefully you all realize it's 0.5, it's a half. So it's 0.5. And the exponents. Again, I'm moving that. Remember, you move this. I want to bring this 2 up top here. I know when I've talked about simplification, we wanted to go from the smallest number to the biggest, but we want to remove the whole fraction of this. So I definitely got to move the 2 up. So it's going to be a positive 2, so it's going to be times 10 to the negative 3. Now again, you might think, oh, I'm done, I did all the work. But not quite, because we didn't have any numbers between 1 and 9 to the left of the decimal. So I'm moving this decimal one place to the right, because now it's 5.0. And because I made that number bigger, okay, I have to make this number smaller. And smaller means it's going to go more negative. So it's going to be times 10 to the negative 4th. All right, let's look at this last one here, 31. 2 times 10 to the negative 5th to the 5th power. So there's 5 of these. Well, again, think of this as, 2x to the, 5th power. That 5 gets distributed to the 2 and to the x, right? From the work we've seen before last week. So this is going to be 2 to the 5th times 10 to the negative 25th. Now, this 2 to the 5th, I have to completely evaluate this. So on a calculator, or if you know what it is, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So I think this is 32 times 10 to the negative 25th. Well, the decimals here, I have 2 numbers to the left, so I'm going to make this smaller, so I'm going that direction. So I have to make that bigger. I have to add to it. So I move one place for the 3.2, and this should be, since I'm adding 1 to the negative 25, it's going to be to the negative 24th, and that's the answer. Okay? Now, homework for you will be these 6 problems right here, 39 through 44. Again, make sure you simplify. Once you get down to, as you multiply, you got to simplify so that you have only one number to the left of the decimal. So you have to adjust your exponent. So numbers 39 all the way to 44. All right, folks, good luck.